Hello, in this video I will be doing some U-substitution integration problems. So this is the first question. I will start by taking the constant out of the integrand using the constant rule, and then I'm just left with sine of 3 minus 7t dt. Here I'm going to let u equal the linear function inside the sine function. And this is the reason why I want to do this is because now by differentiating I can get rid of the constant and just be left with this minus 7. I'm going to switch the dt and the minus 7, so I'm going to be left with dt equals du by minus 7. I can now take the minus 7, the 1 over minus 7 out of the integrand again, so I'm just going to have 4 over 21 integral of sine u du, right, because I'm plugging this in for dt. And then of course the integrand of sine is just minus cosine, because the derivative of cosine is minus sine, and therefore minus cosine derivative will be minus sine. The minus cancel out, so just sine, right? So yeah, and then we said u is 3 minus 7t, and we don't want to forget our constant of integration, which isn't affected by the multiple because it just represents any real number. So we can plug this in here. Okay, I'll do 2 more intermediate questions and 3 more advanced questions. So here we have this reciprocal function, 3 over 4x square root ln x minus 1 dx. I think here it makes sense to let our u function be ln x minus 1, and the reason for this is the derivative is going to be 1 over x, and then we're going to reciprocate it, and we're going to get that du equals dx times x, and the x is going to cancel out with this x. So then we're just going to have our 3 over 4 is going to go out. We're going to just have 1 over root u du, which is just u to the minus 0.5 du, which we can just integrate using the power rule of integration. So let's do that. Du by dx is just 1 over x. That means that well, we can say du equals dx by x, dx equals dux, right? We can put this in for this. We can also take the 3 over 4 out. I'm not going to keep saying it. The constant rule. So then we just have 1 over x root u dux. We just plug this in for dx. This cancels here. This we can just rewrite it as u to the minus 0.5. Because u to the root u is just u to the 0.5, and reciprocating just means minus. So basically I want to add 1 to this and divide by the new power. That's going to be u to the 0.5 over 0.5. We can just write it as over 0.5 is just times 2, right? Dividing by half is the same as multiplying by 2. So then this becomes 2. So our answer, and just don't forget the constant integration, we just have 3 root u by 2 plus. Okay. Okay, one more intermediate question, then, wait, it's wrong. Sorry. Why is it wrong? Oh, I'm stupid. U equals ln x minus 1. Don't forget to resub in your u variable, because of course the computer doesn't know what we let u be, right? So it's an important thing to not forget to do. Ln x minus 1. Okay, so we'll do one more intermediate question, and then we'll do 3 advanced questions. So we'll take out the constant here. We have t times square root 5t squared minus 3. So this is pretty simple. We just let u equal 5t squared minus 3, because the derivative will have t in it, so sorry, dt. So our du will be divided by t, which will cancel with this t. Du by dt equals 10t. Therefore, dt equals du by 10t. So I'm gonna take the 1 over 10 out. That's gonna be 5 over 40. Divide both by 5, 1 over 8. And then you just have t root u du by t. These cancel. This is u to the 0.5, so we just add 1, that's 1.5, and divide by 1.5. Divide by 1.5 is like dividing by 3 over 2, which is the same as multiplying by 2 over 3. So I'll write it like this. This becomes just this, so this is just 12, right? I'm going to put this power as 3 over 2 plus c, and that's our answer. I'll write it more clearly. 1 over 12 u to the 3 over 2. Oh, again, don't forget to 7 your what u is, 5t squared minus 3 to the power of 3 over 2 plus c. Okay. 5t squared minus 3 to the power of 3 over 2 divided by 12 plus c. Okay. Now we will do 3 advanced questions. Okay. So our first question is this one. We can take the constant out. T ln of 2t squared minus 2 dt. So this is pretty easy. Again, same idea. We just want to have the derivative be with t, so then we're going to be able to divide with this t here. And then integrating ln is should be pretty easy. So we're going to let u equal 2t squared minus 2. Means du by dt equals 4t. That means that dt equals du by 4t. Right, we just switch these. Multiply by dt, divide by 4t. Yeah, and then we can just plug this in over here, and we can take the 4 out with the constant rule. We have 3 over 16. And then we just have t ln u du by t. And t's cancel. Now, of course, if we want to integrate the natural logarithm, how do we do that? I think the easiest way to do this is to use integration by parts, which is from the previous video. Basically, we want to make this the derivative, so we can let this. Usually we use u, but because there's already a u here, I'm gonna write the integration by parts formula, but instead of with u, I'm gonna use like m, I guess. So the integral of m dv equals mv minus the integral of v dm. So this is the integration by parts formula. I'm gonna make this be our m, and our dv is just gonna be our du, which means that v equals u, and dv equals du, and we have m equals ln u, and therefore, of course, dm equals 1 over u du, because dm by du is 1 over u, right? So we can just write it like this. So then plugging everything back into this formula, we have the integral of ln u du, which is what we have here, what we're trying to solve for, is equal to mv ln u times u, minus the integral of u times 1 over u du. So this is, of course, just the integral of du, which is obviously just u plus c, because there's lots of ways you can think about this, but 1 is the same as u to the 0. So then just using the power rule, you can just increase the power by 1, so you have u to the 1 over 1. That's just u. So it's going to be just ln u times u minus u plus c. Oh, and of course, don't forget to replug in. U is 2t squared minus 2. Okay, sure, I'll write it here. 2t squared minus 2 times 2t squared minus 2 minus 2t squared minus 2 plus c. Okay. I guess, fine. Make this a plus. I can write it like this. Alright. I'll type it as fast as I can. Squared minus 2 minus 2t squared plus 2 plus c. That is not correct. Interesting. I'm curious, why not? I don't know why. Substitute this. It's exactly what we did. And then, yeah, I don't. Oh, the constant. Okay, so I forgot the constant here. That's why. Yeah. So basically, everything just has to be multiplied by 3 over 16. Don't forget your constants. That's an important message to my mistake. Okay, 2 more advanced problems. Okay, we have the integral again. Take out the constant. This time, hopefully, I won't forget it. We have secant squared. I don't like secant, so I'm just gonna write it as like it's 1 over cosine, right? So just 1 over cos squared ln 4x plus 1 x. Okay. So how will I go about this? So the first step is probably just to let u equal this and let the x's cancel out. So I'm just going to have a power function of cosine, and then to integrate a power function of cosine. Well, we'll get there when we'll get there. The first step is to first let u equal ln 4x plus 1. No, sorry. Yeah. Ln 4x plus 1. That means du by dx. We have to use chain rule here. First we integrate in terms of the natural logarithm, then in terms of the 4. Alright, and in general, when you have a natural logarithm of a constant times x, you're just going to be left with 1 over x, because that's just how it works out always. So yeah, it's pretty cool. Like if you have ln of nx, then it's going to be 1 over nx times n, right? So it's always going to be 1 over x. Okay. So that's this. That means, of course, that dx equals dux, which is going to cancel with this. Oh, I forgot to write the dx here, my bad. So now we have 7 over 8 times 1 over cos squared ln, well, no, sorry, this is just u, cos squared u x, and dx we're going to sub in dux. These cancel. Okay, so now we have this function. How do we integrate this? That's a good question. So in general, when you have 1 over something, you the answer is going to be ln of absolute x. But in this case, we have this cos squared u. So this is interesting. Yeah, I'm not really sure how to integrate this. If we use integration by parts, we can have like 1 over cosine, 1 over cosine. But then we still have to integrate one of these, which don't know how. If we find the derivative of this, what is the derivative? If we have cos to the minus 2 u, the derivative is minus 2 cos minus 1 u times derivative of cosine is minus sine. Could this help us? Maybe. This is just tan u. Okay. Oh, this is sec squared u. Wait. The derivative of tangent is sec squared. Oh, that's right. I can show that real quick, but, well, I basically just did. I showed that well, no, I didn't show it, sorry. But I'll show it real quick. Yeah. Sorry. So this is the integral of sec squared u du. So if you have tangent is sine over cosine, right? Let's say sine cos to the minus 1, right? Well, not arc cosine, right? So let's just do it like this then to show it. So the derivative of this is, we do the derivative of the first one times the second. Plus the first one times the derivative of the second, which is going to be minus 1 times cos minus 2 times derivative of cosine is going to be minus sine. So these cancel. So these cancel. Sorry, I'll do this like better. So if we have sine x over cos x, let's just use the quotient rule actually, not the product rule. So we do the derivative of sine is cosine times the bottom minus sine x times derivative of cosine is just going to be minus sine, right? So this over cos x. But notice how this is 1 by the Pythagorean identity. Cos squared x plus sine squared x is 1. So you just have 1 over cos squared x or sec squared x, right? So if this is the derivative, then the original function must have been tangent, right? So that's why we can rewrite this as 7 over 8 tan u plus c, and of course u is just this, ln 4x plus 1. So 7 over 8 tan of ln 4x plus 1 plus c. Okay, let's try it out. Sorry that took a while, but that's what we're doing here. We're figuring this out. Okay. So this is our 5th question. That means we have 1 question left. This is our last question. Cool. So again, I'll take out the constant. We have t to the 4 over 6 t to the 5 minus 1. I mean, this is kind of similar to what we did, where the t to the 4s are gonna cancel out. But it's not that similar, so I think we can still learn something from this. Of course, we're gonna let u equal 6 t to the 5 minus 1. So our du by dt equals 30 t to the 4. So that means that our dt, we just switch dt in this, equals du by 30 t to the 4. So we have t to the 4 over u squared plus 1. dt is just du by 30 t to the 4. The t to the 4's cancel. We can take the 1 over 30 out. It becomes 1 over 10 if you cancel with the 3, so 1 over 40, right? So we just have now the reciprocal of u squared plus 1. Now, this is another trigonometric identity. I'm pretty sure that this is just the derivative of arctangent. I'm not gonna get into the proof of it right now, but I'm just telling you that the derivative of arctangent is 1 over u squared plus 1. That's why we're gonna have arctangent. And yeah, u squared plus 1, I'll just plug this in already. 6t to the 5 minus 1 squared plus 1. Yeah, plus c. That's our answer. I'm gonna zoom out a bit here so you can see it. This is our final answer. So I wonder if there's something here. Trig functions, yeah. I need this one. Exactly. Arctangent of something squared plus 1 6t to the 5 minus 1. Okay. Over 40 plus c. So that will conclude our video. I hope you enjoyed. Wait, what? Inverse tan 6t to the 5 minus 1 squared plus 1 plus c. That's wrong. Interesting. Wait, what? Why am I adding 1 here? It's just inverse tan of u, right? I don't know why I added 1. That was stupid. That was okay. So that will conclude our video. Hope you enjoyed. Still not correct. Inverse tan of u. Why did I square it? Oh my god. Sorry. Okay. Now that ends our video. I'll erase it. This is our final answer. Okay. I hope you enjoyed the video. Yeah. Our next video is gonna be trigonometric substitution, and yeah, that's it. Thanks for watching.